There is a building material made from sand and salt water that is stronger than concrete, does not crack, does not corrode, and grows harder every decade it stands. The global concrete industry generates $600 billion per year selling you a material that crumbles in 50 years to do what this one does for 500. The material builds itself from the ocean floor. The industry writes the building codes. Your infrastructure is already crumbling. Your highway overpass was built in the 1990s. It is already cracking. Engineers inspected it last year. They recommended repairs. Those repairs will cost more than the original construction. In 20 years, they will recommend replacement. Now here is the part they do not teach in engineering school. 2,000 years ago, Roman engineers poured concrete into the Mediterranean Sea, not onto land, into the ocean, directly into salt water. They built harbors, seawalls, and breakwaters using a mixture so simple a farmer could make it. Volcanic ash, seawater, lime, that concrete is still there, not crumbling, not cracking, not corroding, getting harder. Every single year, that 2,000-year-old concrete gets stronger, not weaker, stronger. The ocean that destroys modern concrete in 50 years is feeding Roman concrete, building it, reinforcing it at the molecular level. Your overpass needs repairs after 30 years. Their harbor needs nothing after 2000. That is not an engineering mystery. That is a buried answer. The material is called Roman marine concrete. The technical name is opus cementitium. The formula has 3 ingredients: volcanic ash from the hills around the Bay of Naples, seawater from the ocean, lime from burned limestone. That is it. No steel reinforcement, no chemical additive, no petroleum product, no factory, no patent. 3 ingredients, 2,000 years, 0 maintenance. Compare that to what is in your walls and under your roads right now. Modern Portland cement concrete is manufactured by heating limestone and clay to 1,450 degrees Celsius. Fossil fuel kilns, industrial grinding, chemical binders, steel reinforcement because the concrete alone is not strong enough. Then it goes into your infrastructure and begins dying the moment it touches salt water. Here is why. Portland cement hardens through a process called hydration. The result is a compound called calcium silicate hydrate. That compound is stable in fresh water. It is not stable in seawater. Chloride ions from the ocean penetrate the matrix. They reach the steel reinforcement inside. The steel corrodes, rust expands, the concrete cracks from the inside out. There is no fix for this. There is only replacement, and replacement is exactly what the industry needs. Roman marine concrete works differently. When volcanic ash meets seawater, a completely different chemical reaction begins. Crystals start forming inside the hardening material, aluminous tobermorite crystals. Interlocking platelet structures growing through the matrix like fingers lacing together. These crystals do not stop forming when the concrete hardens. They keep growing. For decades, for centuries. Every year the structure sits in seawater. More crystals form. Longer, denser, more interlocked. The concrete at 200 years is stronger than the concrete at 10 years. The concrete at 2,000 years is stronger than the concrete at 200. The ocean is not the enemy of this material. The ocean is its manufacturer. In 2017, researchers at the University of California, Berkeley and the Lawrence Berkeley National Laboratory took samples from a Roman harbor in the Bay of Naples. They ran synchrotron X-ray microdiffraction analysis on 2,000-year-old concrete. What they found stopped the materials science community cold. The tobermorite crystals had grown to lengths and densities that no laboratory had ever achieved in synthetic concrete. They were still growing. The study was published in the journal American Mineralogist. The New York Times covered it. Scientific publications in 12 countries covered it. The conclusion was clear. Roman marine concrete does not degrade in seawater. It gets stronger. Modern Portland cement concrete degrades in seawater, always without exception. The comparison was unavoidable. The American Concrete Institute did not update its guidelines. ASTM International, the body that writes material standards for American construction, did not convene a review committee. No building code in the United States was changed. Not a single prescriptive standard was updated. The study was cited 412 times in academic journals within 3 years. It was cited 0 times in any American building code revision document. 0. Now you have to ask yourself why. The harbor at Caesarea Maritima was poured in 41 BC. Roman engineers mixed their three ingredients and poured them directly into the Mediterranean Sea off the coast of what is now Israel. The harbor served the Roman province of Judea for 4 centuries. Then Rome fell. Nobody maintained the harbor, nobody repaired it, nobody inspected it. It sat on the seafloor of the Mediterranean for 2,065 years with no human attention of any kind. Today, it is structurally intact. Marine biologists who study the site say the concrete has become so integrated into the natural reef that distinguishing the Roman structure from natural reef formation requires close examination. The harbor did not resist the ocean. It became part of it. The breakwater at Cosa on the Tuscan coast was poured in 273 BC, still intact. The harbor installations at Anzio, built under Emperor Nero, still intact. Roman fish pens at Torre Stura, constructed in the 1st century BC. Structures that modern engineers put on 40-year replacement schedules have been standing without maintenance for more than 2,000 years. The oldest Portland cement concrete structure in America is the Alvord Lake Bridge in San Francisco, built in already showing significant deterioration. It is younger than some Roman concrete by 19 centuries. It is in worse condition. This is not a coincidence. This is not bad luck. This is not a problem that better engineering will solve within the current material system. It is the predictable result of building with a material that was chosen not because it lasts, but because it does not last long enough. Medieval builders across the Mediterranean knew this without a single laboratory. Arab engineers constructing harbor fortifications at Acre in the 12th century encountered Roman marine concrete foundations already in the seabed. They tested them. They tried to cut through them for new foundations. Their tools wore down. The Roman concrete was harder than the stone they were quarrying from surrounding hills. They documented this. They built on top of the Roman foundations instead of replacing them because nothing they could manufacture matched the load-bearing capacity of what was already there. The Crusaders who took Acre in 1191 made the same observation. Medieval engineers across the Mediterranean consistently recorded that Roman harbor structures outlasted everything built after Rome's fall. Where Roman foundations survived, the instruction passed from builder to builder was clear. Preserve them. Build on them. Do not attempt to replace them. You cannot make anything better. That instruction survived for 1,000 years of medieval construction. It did not survive the Portland Cement Association. Think about what that means. 1,000 years of practical builders passing down the same observation. Roman concrete is harder than anything we can make. Build on it. Do not touch it. That knowledge persisted through the fall of Rome, through the Dark Ages, through the medieval period. Through the Renaissance, practical men with practical problems and practical observations, keeping practical knowledge alive for 1,000 years. Then, in 1924, a trade association in Skokie, Illinois, decided that knowledge was no longer relevant. They were right that it was not relevant to them. It was not relevant to their product. It was not relevant to their revenue. It was not relevant to their replacement cycles, or their inspection contracts, or their quarterly reports. It was only relevant to the bridges and harbors and seawalls that needed to stand. Those things were not their problem. Here is what should make you furious. In 1924, the Portland Cement Association established its research division in Skokie, Illinois. They funded over 400 studies through American universities over the next 4 decades. Every single study examined Portland cement. Not one study compared Roman marine concrete against Portland cement in a marine environment. Not one. 400 studies. 0 comparisons. The association knew Portland cement degraded in seawater. Their own internal documents from the 1930s show that they described marine degradation as an accepted performance limitation. Their solution was not a better material. Their solution was more frequent inspection cycles. Inspection cycles generate consulting revenue. Permanent materials do not. Then they went further. Through their participation in American Concrete Institute technical committees, the association shaped the testing standards that determine which materials get approved automatically and which materials require expensive special review. Portland cement became the default. Everything else became the alternative, requiring documentation, testing, and engineering approval that adds months and money to any project. Cork insulation exceeds fiberglass performance. It requires special approval. Roman marine concrete exceeds Portland cement performance. It requires special approval. The pattern is identical. The industry is different. The mechanism is the same. Write the standard. Make your product the default. Make everything better an exception. In 2004, the United States Army Corps of Engineers began studying Roman marine concrete after repeated failures of Portland. Cement structures in coastal environments generated repair costs exceeding original construction within 30-year windows. They commissioned a technical review. The review concluded that pozzolanic concrete was materially superior for marine construction. They recommended a pilot program. The pilot was approved in 2006, funded at $2.3 million. In the same fiscal year, the Portland Cement Association spent $14.7 million on government relations and technical standards activities. The pilot program was never completed. The findings were never published. The recommendation was never incorporated into any Army Corps standard. The harbor repair contracts continued to be awarded using Portland cement specifications, $2.3 million versus $14.7 million. The better material lost because it could not afford the lobbying budget. Your tax dollars funded both. The pilot that proved the solution and the lobbying that buried it. $2.3 million versus $14.7 million. The better material lost because it could not afford the lobbying budget. Your tax dollars funded both. The pilot that proved the solution and the lobbying that buried it. Now look at what that decision has cost you. The American Society of Civil Engineers publishes an infrastructure report card every 4 years. In their most recent report, America's bridges received a grade of C. There are 431,000 bridges in the United States. 43,000 are structurally deficient. Every single one was built to Portland cement specifications. Every single one is failing the same way. Chloride penetration, steel, corrosion, concrete cracking from inside. The repair bill is estimated at $125 billion. Bridges alone, add the seaways, add the harbor structures, add the coastal highway foundations, add the water treatment infrastructure, add the port facilities. The American Society of Civil Engineers puts the total infrastructure repair need at $2.6 trillion. $2.6 trillion to fix what Portland cement built on a failure schedule. The Roman harbors that are 2,000 years old and still functional did not generate a repair bill. They generated nothing. No inspections, no contracts, no bond measures, no tax increases. They simply stood.